Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. This is lesson 2, describing the center of a distribution. Okay, measure of central tendency. Classwork. In previous work with data distributions, you learned how to derive the mean, that's the average, and the median, or the number in the middle, of a data distribution. This lesson builds on your previous work with a center. Exploratory challenge, exercises 1 through 9. It says to consider the following 3 sets of data. So we have a data set 1 with pet owners. Students from River City High School were randomly selected to asked, how many pets do you currently own? So the key here is a random distribution. How many pets do you currently own? The results are recorded below. So we have 1, 2, 3, 4 said 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 said 1, and so on and so on. And there was actually one student who had 12 pets. Data set 2 says length of the east hallway at River City High School. 20 students were selected to measure the length of the east hallway. 2 marks were made on the hallway's floor, one at the front of the hallway and one at the end of the hall. Each student was given a meter stick and asked to use the meter stick to determine the length between the marks to the nearest tenth of a meter. The results are recorded below. So the measurements were from 8.2 meters all the way up to 8.9 meters. So somebody was not being very accurate if there's 0.7 or almost 1 full meter, which is almost 3 feet difference. Data set 3 says age of cars. 25 car owners were asked what age their car is in years. The results are recorded below. So a car that's 0 years old is brand new. It's a 2019 model, since this is recorded in 2019. And an 8-year-old car, which was built in 2011. Okay, so next page, it says to make a dot plot of each of the data sets, use the following scales. All right, so I copied over the results from pets, and here's how you make a dot plot. There are 1, 2, 3, 4 zeros, so I put 1, 2, 3, 4 dots there. Now I want the dots to line up horizontally and vertically, and we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 ones. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And 1, 2, 3, 4 twos. Okay, I made a mistake already. Okay, I just slid this over. 0, 2, 1 is halfway between, so these should be here. Okay, so let's continue. And now we have 1, 2, 3, 4 that had 2 pets. So 1, 2, 3, 4. Okay, so notice I'm trying to keep these lined up so we can see that 4 equals 4 over here. They're at the same height. All right, so now we have 3. We have 2 that said, or 3, 2 said they had 3 pets. 1 said they had 4 pets. And there are 2 5s, 1, 2, and there are 2 6s, 1, 2, and there's 1 7, and there's 1 8. Oh, what just happened? Okay, 6, there were 2. 5, there were 2. 7, there was 1. 8, there's 1. 9, 1 9, 1 10, and 1 12. Okay, so there is the dot plot for number of pets. Okay, I just copied over the measurements of the hallway so we don't have to go back and forth pages. And 8.2 there was 1, 8.3 there were 2, 8.4 there were 2 people that said it was 8.4 meters long, 8.5, there's 1, 2, 3, 4, 5. 8.6, there's 1, 2, 3, 4. And 8.7, there were none. No, there were. 8.7, there's 2. 8.8, there was 2. And 8.9, there was 2. So there's the dot plot for east hallway length, measures in meters. Okay, I copied over the age of cars data, and one person said their car was new, or 0. And one said their car was a year old. 2 said their car is 2 years old. 1 said their car was 3 years old. 1 said their car was 4 years old. 2 said 5 years. 3 said 6. 1, 2, 3, 4, 5, 6 said 7 years old. And 1, 2, 3, 4, 5, 6, 7, 8 said 8 years old. Okay, so there's our dot plot for age of cars. Now number 2 says, calculate the mean number of pets owned by the 30 students for River City High School. Calculate the median number of pets owned by them. So we want the mean and the median of this data set right here. Okay. Let's do the median first. In order to do the median, when we have them in order already, then I know that there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 30 of them. So if I go this way and cross these out and go this way and cross these out, and my two numbers in the middle, if we have an even number of data sets, you add the 2 in the middle and divide by 2. So it'd be 2 plus 2 divided by 2, which is 4 divided by 2, or simply 2. So when they're equal, it is that number. All right, so here the median equaled 2. Now I'm going to determine the mean. And the mean is the average. So let's go back up to this data set and erase the crossed out stuff. Okay. And now we want to add these up. Well, there's an easier way to do it than to say 0 plus 0 plus 0 plus 0 plus 1 plus 1 plus 1 all the way down. I'm going to use multiplication to help me. So 0 times 4 is 0. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Is that right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 times 1 is 10. And then 1, 2, 3, 4 twos. 4 times 2 is 8. And then 2 times 3 is 6. 4 times 1 is 4. 5 times 2 is 10. 6 times 2 is 12. 7 times 1 is 7. 8 times 1 is 8. 9 times 1 is 9. 10 times 1 is 10. And 12. Okay, so it makes it a little bit easier if you have a lot of data to do this multiplication. So 10 plus 8 is 18. And here's a 10 here, so that's 28. 38. And 10 more would be 48 plus this 2 is 50. 57. 57 plus 8 is 65, plus 9 is 74, plus 10 is 84, plus 12 is 96. So the mean equals 96, that's the total, divided by how many there were. And there were 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 times 2 is 30. 96 divided by 30. Hey Siri, what's 96 divided by 30?
96 divided by 30 is 3.2.
Okay, so the median was 2 and the average or the mean was 3.2. Number 3, what do you think is a typical number of pets for students from River City High School? Explain how you made your estimate. So now when we look at the mean and the median, our median was 2 and our mean was 3.2. Okay, so what they're asking is which would be the better measure of center to use in this situation? What would be a more accurate description of our center? Do we want to use the median or we want to use the mean? So if we come up and now we want to focus on the dot plot. So if I took the average, which was 3.2, that is right about here. The median is right here. Okay, so which one would be a better representation of how many pets students had? And since the median is less than the mean because more of the data is located on the left side, so the median is less than the mean because more of the data is over here. The value of the mean is pulled up by larger values. This 12 way out here pulls up the average, so the median would be a better representation. And you'd say because the large values pull the mean up and more data is to the left, and that's why the median is less than the mean. Number 4 says, why do you think that different students got different results when they measured the same distance in the hallway? It depends on where they place the stick. If they're using a meter stick, okay, so they had this meter stick, and then they measured the floor to here, and then they lift it up, and then they set it back down. Well, if they weren't accurately setting it down where they left off and left a gap, or maybe the next time they measured what they've already measured before, then their values are going to be off. So if then again they go like this and they're measuring and they skip this area here, so it's going to be an accuracy error. Okay. Number 5, what is the mean length of the East Hallway data set and what is the median? So I'm just going to write mean equals and median equals, and now I'm going to go back and look at the data set of the hallway. So we're going to do the same thing we did with the pets. 8.2 times 1 is 8.2. 8.3 times 2 is 16.6. Let me move these up here. So it's going to be plus 16.6 plus 8.4 times 2 is 16.8 plus 8.5 times 5 is let's see, 42.5 plus 8.6 times 4. 8 times 4 is 32. 6 times 4 is 2.4. 34.4. 8.7 times 2 is 17.4. And 8.8 times 2 is 17.6. And 8.9 times 2 is 17.8. Okay, so let's just line these up this time. I'm not going to cheat using Siri. I'm just going to do the math. Just copying what I multiplied by different portions. 17.4. The next one's 17.6. And 17.8. All right, so 2 plus 6 is 8, 16, 21, 25, 29, 35, 43. Carry the 4. 8 plus 4 is 12, 18, 24, 26, 37, 44, 51. Carry a 5 over here. 5, 6, 7, 11, 14, 15, 16, 17. 171.3. Now don't forget we have to divide by how many we had, and it was 1, 2, it was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times 2 rows is 20. So 171.3 times 20. Okay. Hey Siri, what's 171.3 divided by 20?
171.3 divided by 20 is 8.565.
Okay, so our mean is 8.565, and now we want to look at our median. Okay, so this time we have an odd number of values, so our middle number is going to be our median without dividing. Okay, so I just crossed out 9 from the bottom, and I went backwards 9 from the top, leaving me with this number here is 7. The median is 7, and the mean is 8.565. Okay, I looked at the wrong values, didn't I? So now I just did the median for the next set because I had the hallway here. What I want for my median is the middle two numbers averaged. 8.5 and 8.6, my fault. It is not 7, it's 8.5 plus 8.6 divided by 2. Since there were an even number of data points. 6 plus 5 is 11, carry the 1. 8 and 8 is 16, plus 1 is 17.1 divided by 2, which equals 8.55. Okay? So we have 8.565 as our mean and 8.55 as our median. 6. A construction company will be installing a handrail along the wall from the beginning point to the ending point of East Hallway. The company asks how long the handrail should be. What should you tell the company and explain your answer? Okay, so do we want to go with the mean or do we want to go with the median? That is the question. Okay, so it should be approximately 8.6, I would say. 8.55, 8.565. So I would say approximately 8.6 meters. Since the distribution is nearly symmetric, the mean should be used as a measure of central tendency. Okay, so what that means is looking at this data, see how this data is nice and centered? It looks like a nice bell-shaped curve, and our data is centered, so we would use the mean. Whenever it's skewed, you want to use the median. So we use the mean, and the mean was 8.565, which is pretty close to 8.6 meters. Number 7 says to describe the distribution of the age of the cars. So when I look at the age of the cars, we want to look at the graph. It is definitely skewed left. We have data building up on the right. Cars are older, so it is definitely skewed. Okay, so that's what I'd say about that, skewed left. The next problem says, what is the mean age of 25 cars and what's the median? Okay, so they want mean and median again. So I'm going to write mean equals and median equals. Go back to this time. Okay, I already crossed out. This was an odd number, so it's the middle number this time. The median is 7. Okay, I already calculated that last time by mistake. And now we're going to do the average. And I'm going to use multiplication again to simplify this. And I'm going to write my answers vertically one time. So 0 times 1 is 0. Plus 1 times 1 is 1. Plus 2 times 2 is 4. Plus 3 times 1 is 3. Plus 4 times 1 is 4. Plus 5 times 2 is 10. Plus 6 times 3 is 18. Plus 7 times 3, 6 is 42. And 8 times 1, 2, 3, 4, 5, 6, 7, 8 is 64. So I'm just simplifying my addition here by using multiplication from each. Okay, forgot to mute my phone, but here we go. 0 plus 1 plus 4 is 5, 6, 7, 8, 12, 22, 26, carry the 2 right here, 3, 4, 8. And 6 is 14. So That is 146. Mean is 146 divided by our total number of data points, which was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 24, 25. 25. Hey Siri, what's 146 divided by 25?
146 divided by 25 is 5.84.
Okay. What number would you use to estimate the typical car age of the 25 car owners? Explain your answer. So median 7, mean is 5.84. Which is a better center is what they're asking. Go back, look at your data, and since it is skewed, the average is dragged down by smaller values way over here. We want to use the median because it's closer to the bigger values, the more numbers. So we want to use the median. And I would use the median of 7. The median of 7 as center, because the data is skewed. So we look back again, 7 is right here. I would use this because there's several over here to the right, several right here, and this total here would probably be pretty close to the total of these here. So 7 is a better center than our average, which was down around 5. Okay, that is the end of lesson 2. Review your lesson summary and go do your problem set.